welcome to the first of a number of tutorials that I'm going to give on fractions. Now, fractions are a topic that seem to cause tremendous difficulty with students. If ever there was a topic in basic maths that really held people back and that people lost confidence with, it is fractions. So my intention in this tutorial, and possibly 3 or 4 more that follow, is to give the clearest exposition that I can of what a fraction is, how to manipulate them, how to do arithmetic with them, so that if you're able to study these tutorials carefully and practice, you will be fully confident and comfortable with fractions. Now you might ask, well, I don't like fractions, so why should I bother learning them? The answer is that really they are as natural in mathematics as the counting numbers, the integers that we talked about in the tutorial on numbers. Fractions are everywhere around us. They appear throughout science. They also appear in the media, from politicians, from journalists, in economics. They are absolutely fundamental to the way we understand ourselves and the world. And if you're comfortable with fractions and can manipulate them, you will have a much greater ability to not only understand the world around you, but also to judge it and to understand whether things that you're being told are reasonable or unreasonable. Don't be someone who is easily confounded by fractions. Fractions are the language of percentages, they're the language of geometry, the language of trigonometry, the language of statistics. As I say, they appear throughout science, mathematics, and other areas of life. So I'll start very gently in this tutorial defining fractions, and I'll also go on to talk about how to convert between what's known as a mixed fraction or a mixed number and a top-heavy fraction. And if there's time, I'll also talk about how to simplify fractions. And then in forthcoming tutorials, I'll talk about arithmetic with fractions and also how to do algebra with fractions as well. As I say, in my experience of teaching, these topics seem to cause students great difficulty at all levels, in fact, but I think that it's fundamental to further study in maths to be very comfortable and very confident in dealing with fractions. Otherwise, one is trying to do the rest of maths with one's hands tied behind one's back. Well, I think no introductory lecture on fractions can do without a picture of cake or pizza, because it's such a nice way to introduce the topic. I think because I'm British, I will choose cake. If I were American, no doubt I would choose pizza. So let's imagine then that there are some parties going on, and birthday parties, of course, and that birthday cake is being served. So here is a top-down view of a cake, and let us say that the host is expecting 3 guests, and therefore with 4 people coming to the party, the host slices the cake into 4 even slices. There we are. So it is obvious to us that there are 4 quarters in this cake. So we can think of a quarter as one of the slices of this cake, and we represent that mathematically by writing 1/4. Literally we say 1/4 or 1/4 in this case. Let's imagine, for the sake of argument, that one of the guests fails to attend the birthday party, and so the host has their piece of cake, and the two guests each have their pieces of cake, and we can ask how much of the cake has been eaten, and the answer is that 3/4 of the cake has been eaten. And so the shaded area there, we could say, is 3/4. Now, it's obvious at one level, but apparently not obvious to many, that a very natural way to think of this is to write it as 3 lots of a quarter. 1/4, a 2nd quarter, and a 3rd quarter. 3 lots of a quarter, which you can equally well write as 3/4 or 3/4. Let's just do another example. So there's a different party going on. They have apparently a bigger cake. Lucky them. However, there are more guests. There are 6 people in all, the host and 5 expected guests. So let's try to divide this cake into 6 equal parts. Try to do that approximately. Anyone who's tried to cut cake for 6 knows that that's quite tricky. There we are. So in this case then, we have a 1/6 is the slice of cake, and we can write that as 1/6, 1/6. Let's imagine in this case that 2 guests failed to come to the party. There must be some difficulty with the public transport. The host has their piece of cake, and let's see, there would be 3 guests that arrived. They each have their cake, and that's how much cake is eaten. So in this case, the shaded area is equal to 4 slices, 4/6. That's a hard word to say. And again, it's very clear from the picture, but not always clear when one's doing just maths in real sort of time, that one can very naturally write this as 4 lots of 1/6, because 1/6 is a slice. Okay, so maybe I can just write that for each of these, that we're talking about 1 slice, okay, of the cake, when we talk about a quarter in that case, or a 1/6 in this case. So the shaded area here is 4/6. Okay. Notice that we could sort of imagine, let me just get a different coloured pen, in fact. We could imagine here the cake sort of being in 3 groups, where each group has 2 slices. Yes, that's right. So what's happened is that the host and 1 guest have eaten 1 group, the other 2 guests have eaten the other group, and then the 3rd group here has remained uneaten because those 2 guests did not arrive. So we can also see that the shaded area is equal to 2 of the 3 groups, each group being 2 slices. And therefore we can see that there is no difference between 4/6 and 2/3. And this in fact is an early example of something we'll talk about a little later in the tutorial, about simplifying fractions. So it's just our first example of simplifying. We were easily able to show from the picture that 4/6 is the same as 2/3. And a way to understand that is to think of 4/6 as 4 is 2 times 2, and 6 is 2 times 3. And the rule for fractions is that if you have the same factor in the top and the same factor in the bottom, you can cancel them out, and you see that reduces then to our 2/3. And we'll come back to that a little later on when we're simplifying fractions. A little bit of notation. If we write a fraction, for example, 3/4, so I'm just talking about notation here for a moment. The top of the fraction we call the numerator, and the bottom of the fraction we call the denominator. So you'll sometimes hear me speak of numerator or denominator, and by numerator I mean the top of the fraction, and the denominator I mean the bottom of the fraction. Now let's talk about something that's very important, and again often confusing, is converting from what you might call a mixed number or mixed fraction to a top-heavy fraction. So I'm using these terms as they're terms that you may have come across at school or in your former studies. These terms are not set in stone. Sometimes one refers to a top-heavy fraction as an improper fraction. If you've seen the tutorial that I made on numbers, we talked about rational numbers as fractions of integers, and we saw there it's very natural to think about fractions that are improper or top-heavy. They appear very naturally on the number line. So let's say, well, what is a mixed number? So let's just consider then that there is a party where 2 cakes are made. And for the sake of argument, let's say that each cake is cut up into 3 slices. And let's say that the host was expecting 5 guests. 1 failed to appear. The host had their slice. Of the 4 guests that arrived, 2 had the slices from this cake, and then the other 2 guests each had a slice from this cake. And so now the shaded area is equal to 1 whole cake and 2/3 of the second cake. And there's a very odd notation that we use in maths. It's just historical because it's so odd you'd never invent it if you were doing things anew. But there's an odd notation we use for this. We write it as 1 and 2/3. Now generally in maths, as we'll see when we do algebra, if you have 2 symbols next to each other, there is an implication that you're multiplying them together, but that's not the case with these mixed numbers. Actually, this literally means 1 and 2/3. Now, we can also see, though, if we just count how many thirds are there that have been eaten, it's 1, 2, 3, 4, 5. So this is equal to the top-heavy fraction 5/3. The way to convert between these, there's a sort of a quick way that I possibly wouldn't recommend, but it does work, and it's quite popular with some folks, is to multiply this denominator by the whole number, add the numerator, and then put everything over that denominator. So you would have 3 times 1 is 3, plus 2 is 5, and then you'd put all that over 3. So let's just do another example. Let's say we had 2 1 3/4, for example. This method, you would take this denominator, you would multiply it by the whole number, add the numerator, and put everything over the denominator. So you'd have 4 times 2 is 8, plus 3 is 11, and then you would put all of that over 4. And that makes sense because this would refer to someone who had made 3 cakes, cut each of them into quarters, and all but one slice were eaten, and so the shaded area, if I were to draw this, would be 2 whole cakes and 3 slices of the third cake. In all, 11 slices would have been eaten, and each slice is a quarter. And again, just to remind you, you're perfectly able always to write a fraction as the numerator times 1 over the denominator, and it makes it very clear then we're talking about 11 lots of a quarter in that case, just as here we're speaking of 5 lots of a third. Just to end this tutorial, another way to convert between a mixed number and an improper fraction is to think of it like this, that 1 2/3 literally means 1 2/3. The 1 in this case represented this cake of 3 slices, so there were 3 thirds. And then we're adding 2/3, so we have 3 lots of a third plus 2 lots of a third. So I'll write it very explicitly. 3 lots of a third plus 2 lots of a third. And we see then how many lots of a third do we have? We have 3 plus 2 is 5. 5 lots of a third. So this is a perhaps more clear way to see why 1 2/3 equals 5/3. If you're in a hurry though, it's very straightforward just to use this trick where you just multiply, as I say, the denominator by the whole number, add the numerator, and divide by 3. What I've seen with many students is that they sort of know this trick, but they don't really know why it works. And I think you always want to avoid that in mathematics. You always want to be able to understand exactly what you're doing. And so if you use a trick or a fast method, that's absolutely fine, but be sure you know the underlying reason why that is correct. Because maths is not a bag of tricks. It's a beautiful logical structure where everything connects to everything else. And if you take the time to learn it carefully, it will reward you by always being clear, and you'll always know how to get from A to B. Right, so that's the end of this first lecture on fractions. In the next one, we'll talk in more detail on simplifying fractions. We'll talk also about doing arithmetic with fractions, and perhaps with 2 or 3 more tutorials we'll be able to cover that and also talk about doing algebra with fractions as well. I hope this has been a helpful introduction, and I'll see you next time.